Hi everyone, this is Mrs. Finholm recording a lesson for 7th grade math at Red Wing High School. Today's lesson video is the review video for concept number 11. This is day 4 of our lesson time spent on concept 11, working with proportions, conversions, and constants of proportionality. So as you can see, this is our review lesson, and so you should make sure to watch and make note of this video before taking your concept assessment today. And you can see here our standards that we've spent the last several days working on, being able to solve multi-step problems. That's something several of us still struggle with. We want to be able to do it in one quick step in our head, and sometimes that's just not possible. We have to write things down to solve proportional relationships. So let's look at and do some examples together here. Let me get to the correct pen. All right, there we go. So, this is a follow-up and help problem from the 3-6 Math Excel, your homework from yesterday. So the table lists recommended amounts of food for 23 party guests. So I know that 23 guests will need to use these amounts of food over here on the chart. So I'm going to actually look at, I worked through in class with several folks the chicken example. I'm going to do the deli meats example as another review problem here. So 23 party guests will use 3 2/3 pounds of deli meat. And we want to know how much meat should they plan for if they have 40 guests plus drop-in guests. So this is where several folks missed this little detail right there. Each drop-in guest is going to count as half of a guest. So I have 40 plus half of 35 because a drop-in guest might have eaten at another party and so they're not quite as hungry. So half of 35 is 17.5. So I have 40 plus, oops, what happened to my pen? Plus 17.5. That's how many guests I want to plan for. So you need to make sure that you read your directions and steps carefully so that you don't miss that extra detail of taking half of the drop-ins. So we want to know how many will I need for 57.5 guests. Now that I have my proportions set up, we can cross multiply to solve this problem. So I'm going to cross multiply, and I end up with 23 times x equals 3 2/3 times 57.5. Now it's kind of yucky to have one as a fraction and one as a decimal. So you could rewrite this as 57.5, or we could turn this into a decimal in our calculator. I know that 2/3 is 0.666 repeating, so I'm going to round that to 3.667. And the opposite of times 23 is to divide by 23. Now remember, when you're doing this problem, it's going to have different numbers and different values to put in, but your process will be the same. We'll take the number of guests over the amount of meat we know, and we'll use a proportion with the number of guests I plan on having over my unknown, and then we cross multiply and divide. All right, let's look at another example. Okay. Emily and Andy go to a hardware store to buy wire. The table shows the cost in dollars for X inches of wire. How much will each of them spend? So the challenge here is that Emily's is in feet, and I need to know what it is in inches. So I'm going to take my 25 feet and I'm going to put it over 1, right? Actually, I'm not going to put it over 1. I'm going to erase that. Okay. I'm going to get back to my right pen here. Okay. So I've got 25 feet and I don't know how many inches it's going to be. But I do know that 1 foot equals 12 inches. So I'm focused on Emily right now. My table is in inches and my wire is in feet, so I'm converting it into inches. I said 25 feet is how many inches if 1 foot is 12 inches. And now we can cross multiply just like we learned and practiced in our concept yesterday. And I find that 1 times x, well, that's good because 1 times x is just x, equals 25 times 12. So the number of inches that Emily needs is going to be her feet times 12, which is 300 inches of wire. So now there are a couple of different options that we could use to try to figure out how much she's going to pay. One option would be to figure out, is there a way to add up some of these different lengths to equal 300? If there is, we could add up and combine those prices. The other option is to use a proportion again. So 130 inches costs $9.10. 300 inches will cost what? And once again, we can cross multiply. 130x equals 910 times 300. The opposite of times 130 is to divide by 130. And we can find Emily's cost for the wire, 9.10 times 300 divided by 130 tells us that she's going to pay $21 for her wire. So in this problem, we actually used 2 proportions. This was a multi-step problem where we had to first use a proportion and cross multiply and divide to find our inches, and then set up another proportion and cross multiply and divide to get our cost. All right, so unit price. Another thing that you'll see on your concept assessment today is finding the unit price. The unit price is another word for K, or our constant. And so in this case, we have a price of $37.14. So I want my cost per sock, or per pair of socks. So we're going to take 37.14 divided by 6. If I divide my total price by the amount of items I'm buying, I find that my unit price for these pairs of socks is $6.19. I'm not going to try to type it in that teeny tiny little box. I'll just write it over here to the side. So we want to remember that unit price means what is the cost of one thing. Let's look at another example that mirrors things that we'll see on our test today. So the tables show the numbers of yellow and white flowers that Kara and Hector use in 5 different arrangements. Are Hector's flowers arrangements proportional? So to test for proportionality, we want to take our y over our x. So I've got my y and my x. Remember that proportionality is always y over x. So I have 6 over 4, 10 over 8, 14 over 12, 18 over 16, and 22 over 20. Okay. And so now we're going to divide them and see, are they all equal? Are these ratios equivalent? If they are, then we know that the relationship is proportional. So right off the bat, we see here that they are not proportional because the first fraction is 1.5 and the second fraction is 1.25. So as soon as you get one that's not equal, you can say that no, they are not proportional. Okay, but let's just pretend. So we know that they're not proportional, but now let's say that Hector wants to make it proportional. And he says, I want to have a constant of proportionality of 1.5. So if Hector says, well, I really want to be more uniform in my flower displays, and so I'm going to use 1.5 yellow roses for every white flower that I put in my bouquets, what would my equation be? And so our equation, recall, is y equals k times x. And so we could plug in our k value. And then let's just say that Hector then said, well, someone just ordered a bouquet that has 20 white roses in it. How many yellow do I need to order? And so we would take 1.5 times 20 to find our answer of how many whites we need. And so we would, or yellow roses, I'm sorry, wrong color. Would need 30 yellow roses if we were doing a bouquet with 20 white flowers in it. So there's a review problem for you of how to test for proportionality. We divide y divided by x, y divided by x, y divided by x, y divided by x. If they are all equal, yes, it's proportional. In this case, no, it is not proportional because the fractions are not equal. If you want an extra practice problem before you take the test, you could answer this same question for Kara's flower arrangement. Are Kara's flowers proportional? And if they are, what is their constant of proportionality? All right, I think I have time for one more problem here. So Natalie walked 3/5 of a mile in a half an hour. How fast did she walk in miles per hour? So miles per hour means miles per hour, miles over hour. So I have 3/5 over 1/2. This is a review skill for us from concept 9. When we're dividing fractions, it's the same as multiplying by the reciprocal. So I'm going to multiply both parts of my fraction by 2 over 1. When I do that, my 2's cancel, and that becomes 1, which goes away. That's good. 3 times 2 is 6. And 5 times 1 is 5. And so they went 6/5, which is the same as 1 and 1/5. 5 times 1 is 5, plus 1 is 6. And so they went 1 and 1/5 miles in 1 hour. We divide those complex fractions by multiplying by the reciprocal. Make sure you review these examples before you take your concept assessment.